You are welcome to today's video lesson with Bright Edu. In today's lesson, I'll be discussing about the calculations in electrolysis, whereby we'll be solving various practice questions that cut across this aspect of chemistry. Meanwhile, in the course of today's class lesson, I will arrange every single aspect into cases so that it will be easy for you to assimilate. Now, if you are just joining this community and you haven't subscribed yet to this channel, do well to click the subscribe button to this video and also share these video lessons with your friends. So let us start. So you can see this is case number 1. So we'll be solving questions that cut across this case, and it is on Faraday's first law of electrolysis. I already have a video lesson whereby I taught on the derivations of all these formulas, which I'm going to put the link up here. So after watching this video, you do well to go watch that particular video lesson. But knowing the formula is very important. In that particular video lesson, I just did the derivation, okay, and we solved questions. But in the course of today's lesson, I'm going to solve a lot of practice questions so that when you see questions under this aspect, you can be able to tackle them without stress. And it's basically, you can see we are in the first case, which is case number 1, and it is on Faraday's first law of electrolysis, whereby you already know that the Faraday's first law of electrolysis states that the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. That is what the law states. But in the course of today's lesson, I'm going to just write out the formula and tell you what each of the parameters mean in the formula so we can start solving practice questions. So the formula to take note of under this case, which is on the Faraday's first law of electrolysis, is simply this, is equal to M, which is mass, is equal to ZIT. So this is the formula that you must take note of when you are solving questions under this aspect, where I'm going to talk about what each of the symbols mean. Where M, let me write out the symbols, M, Z, I, and T. M, Z, I, and T. So what does M signify? M basically means mass, and mass must be expressed in grams. This is something that must be noted, whereby Z is called a constant, or basically an equivalent. It is called the electrochemical equivalent. That's something you must take note of. What's Z called? Is called the electrochemical equivalent. So this is something you must take note of. Now you might be wondering, how do I know that this is the formula I have to use to solve this question? Now this is something you must take note of. You must take note of whenever you are solving questions on electrolysis and you just see this word or this term in any question at all in electrolysis, and you see electrochemical equivalent, your mind should go to this formula. Okay, so you can see that the order here is I, and I basically is called current, and current must be expressed in amperes, whereby T here is time, and time must be in seconds. So you can see all what each of the parameters in this formula mean, so that without wasting much time, let's impute all the parameters in the question into all these and solve and get the mass as stated by the question, whereby I read. The question says, given the electrochemical equivalent of a metal as, so they gave us the electrochemical equivalent of this metal as this value, and what was it? It is 3.6 times 10 raised to minus 4, full stop. Calculate the mass of the metal. That means they are asking us to get the mass of the metal that will be deposited when a current of 4A, A means amperes. So 4 amperes is passed for how many seconds? It's passed for 120 seconds. Now this must be noted. It must be noted that whenever you are solving questions in electrolysis, your time must always be in seconds. So for instance, this time given in this question was a minute. We have to convert to seconds. For instance, it was in hours. We have to convert to what? Seconds, whereby we simply solve and record the formula again, which is M is equal to ZIT, and what is our mass we are looking for in grams was our Z electrochemical equivalent is 3.6 times 10 to the minus 4 times was our I, which is current, is 4, okay, 4 amperes, times was our T, which is time, 120 seconds. So what becomes mass when we impute this into the calculator? We have 3.6 times 10 raised to minus 4 times 4 times 120 seconds. The mass we are having here is 0.1728 grams. So you can see how questions on these aspects are being tackled without stress. So I'm going to give you your own practice question so you can solve and provide the answer in the comment section below. Okay guys, this is the practice question you are to solve and provide the answer in the comment section below. So with all this said, let's get into the second case in solving calculation questions in electrolysis, which is case number 2. Okay guys, moving further to the second case in solving questions in electrolysis, and the case is basically titled General Calculations Seen in Electrolysis. And for we to solve questions of this sort, we have to know a formula. Recall I said I already have a video lesson that explains the derivation of all these formulas I'm writing here. But you know, when you're writing exams like the JAMB examination, okay, you basically don't need to know or too well the derivation. All that matters here, you know the formula so that you can be able to apply and solve the question. But if you're writing theoretical exams, knowing the derivation is very important also. So you can go watch the video lesson, which I said I'm going to put the link up here. So you go watch the video lesson. Meanwhile, you can see that they are still asking us to get what? Mass. What mass? Recall the previous case basically explains what mass. Do you get? In the previous case of question we solved, they were still asking mass. Here they are still asking mass. They can ask anything, okay? But the reason I'm doing it this way so that it can be easy for you to assimilate very well. But to differentiate this question from the other question, as you are looking at this question right now, are you seeing electrochemical equivalent? No. Since we are not seeing electrochemical equivalent in this particular question, so definitely we are not to use the Faraday's first law or pattern to solve this particular question. We're going to use the general calculations seen in electrolysis, which I'm going to write here, the formula. So the formula that must be noted when solving questions of this sort, that's what I'm writing here. And now since they're asking us to get mass, and the formula basically just starts with mass, is equal to molar mass. Mass is equal to molar mass times I times T over Q times F. So this is the formula used to solve questions, okay, general calculation questions in electrolysis, whereby we'll be solving this question together. So let's write out the parameters we are saying. But now I can see some symbols which the meaning is not being written, which I'm going to talk about the meaning. So this is I, this is T, this is Q, and this is F, as earlier said. Now, what does I mean? As earlier said, I said I is basically current in amperes, and T is time in seconds. And what does this Q mean? Now, this is what I want to stress on. It must be noted that Q here simply means charge of element. This is very important. Q means what? Charge of element. I'm going to talk more about this. In the previous lesson I did on electrolysis, I explained some popular elements and their charges, which basically I'm still going to talk here in this video lesson. And this is F, called the Faraday's constant. And Faraday's constant basically is a value, and it is 96500 coulombs. Whereby, how do we get our current is given in the question. How do we get our time is given in the practice question. Charge of the element, we have to determine that, and F is the Faraday's constant, whereby for the mass, that is what the question is asking us to get. What mass? What mass? And how do we get the molar mass? The molar mass is already given in the practice question, and it was 197, because we are interested with what mass of gold. Remember, gold is symbolized as AU. So what becomes the molar mass of gold? You can see it here. It is 197 grams per mole, whereby our mass will now be equal to, now what's the current as given by the question? it is 15 amperes. So here becomes 15A. And what is the time in seconds? Remember, your time must always be in seconds. It is 130 seconds. Okay, and how do we get charge of the element? Now, this is where you have to pay close attention. To get charge of the element, you have to look at the compound that was mentioned in the question. Note, when solving questions in electrolysis, we don't basically calculate molar mass for the full compound. What we are interested in is the element they mentioned, and it is what? Gold. And that is what they will give you the molar mass for. Are you seeing what I'm saying now? So you can see here that as specified by the question, the gold they said, because charge is basically a value that is on top of a particular element. Okay, and gold is a metal, and metals, they are positively charged. Do you get? So now they stated gold 3. Okay, gold 3. Gold is AU, and now since they stated gold 3, it becomes AU3 plus, because as earlier said, metals are positively charged. That's why it has a plus charge. Okay, so moving further, what becomes our charge? That's the Q for gold. The Q for gold becomes 3. So here becomes 3, whereby our mass, let's impute, the molar mass is 197 grams per mole times what's our I, which is the current in what? Amperes, and it's 15A, was our time 193 seconds over what is our Q, which is the charge of the element. It is 3 times what's Faraday's constant is 96,500 coulombs, whereby mass, when we impute all these into the calculator, what becomes what we get? 197 times 15 times 193 over 3 times 96,500. That is 1.97 grams. So you can see how it works. The answer we are getting now is 1.97 grams, and that is the mass of gold that will be deposited during the electrolysis of gold 3 tetraoxosulfate 6. You can see solving questions of this sort is very, very easy. And if you find this video helpful, do well to click on the subscribe button to this channel, and also share these lessons with your friends to help one another. Meanwhile, you have to solve your own practical question and provide the answer in the comment section, whereby I'm going to change some of the parameters here, and you have to solve for the mass of copper. Copper is symbolized as Cu of, let's say, copper 2 sulfate, copper 2 tetrasulfate 6, when a current of, let's change here to like 10 amperes, is passed for, let's say here is 200 seconds. So you provide the answer in the comment section, whereby for the molar mass of copper is 64 grams per mole. So you do well to provide the answer in the comment section. So we'll progress to the other case, which is case number 3. Okay guys, let's get into the third case on electrolysis calculations, and it is calculations in electrolysis dealing with volume. Now this part is very important. You have to pay close attention to every single steps that are being followed to solve this particular question. Okay, and the question says, what volume of oxygen? So first of all, we have to be careful with this statement. That means they are asking us to get volume. What volume? And if you observe, when we're solving questions on other cases, did we mention anything like volume? No, we did not. But I'm going to bring our volume into those formulas being written earlier, okay, by a derivation. Now, this is the only case of question I will be deriving the formula. Okay, I can decide to just write out the formula, but it's still good for you to know how the formula was gotten. That's what I'll be deriving here. So right now, we have to go back to case number 2. Okay, case number 2. And let's solve this question together before I even read the question out. So let's go from case number 2. Okay, from case number 2, what was the formula? We had a formula that says mass is equal to what? Molar mass times I times T over Q times F. This was case number 2 formula. So I want to derive this formula for electrolysis calculations dealing with volume. So we have to note this. You have to remember this also. In science, Q is equal to IT. Now, you want to ask, what does this BQ mean? This BQ means quantity of electricity. And BQ is different from small q. This one means charge of element, while this means quantity of electricity, and it is expressed in coulombs. So this will now come to your mind that this particular value I'm seeing, what is it called? Quantity of electricity, because I said now that quantity of electricity is expressed in what? Coulombs. So definitely this number I'm seeing here is this particular value, which is q. Now we are coming, we'll solve the question together. So since I've said that q is equal to IT, so this place I'm having IT, I'll remove it and put q there. So we are having mass will now be equal to molar mass times the big Q now, which I've interchanged, over small q times F. So moving further, let's make big Q subject of formula. So doing that, big Q will now be equal to mass times QF over molar mass. So we are having mass times Q times F over molar mass. So you can see what we've arrived at. We are coming somewhere. Now you can see that I'm having an expression here in this formula that says mass over molar mass. Yes. Though the formula we had is mass times Q times F over molar mass. But I can see something here which is mass over molar mass. And from normal science, from chemistry introduction, the concept of stoichiometry, I have a video lesson that explains stoichiometry, so you do well to go watch that particular video. The link will be up here. Okay, so you click on that link and go watch the video lesson. Meanwhile, from stoichiometry, we have a formula that relates mass over molar mass, and what is that? It is number of moles, which is what? N. Number of moles, which is what? N. And in that particular video lesson, I made mention of various formulas for solving number of moles, which is N. So when they ask you number of moles at STP, whenever you see STP in a particular question, which means standard temperature and pressure, number of moles at STP is quite different from number of moles, this particular number of moles. So number of moles at STP is equal to a formula which is volume in dm cube over 22.4 dm cube. Are you see what I'm saying now? So my point here is this: generally, number of moles is mass over molar mass. But number of moles at STP is what? Number of moles is equal to what? Volume in dm cube over what? 22.4 dm cube. So my point here is this: this mass over molar mass will be changed to N, because yes, that's what we are driving towards. So now Q will now be equal to NQF. This formula being derived is very important also. We are coming towards, because this formula will help us solve another question in another case, whereby you can see we've gotten the expression. And now Q will now be equal to this, my N now that was mass over molar mass. I will change it to this particular formula, which is now number of moles at STP, which is volume. Okay, volume in what? dm cube over 22.4 dm cube times, you write Q times F. You can see how it works. Okay, so right now we are to make what subject of formula? Volume. Volume in dm cube subject formula. What are we having? Okay, doing that, we will have Q times 22.4, which is Q times 22.4 dm cube over small q times F, whereby you can see the formula to solve questions in electrolysis when volume you are asked. When they ask you to get volume, this is what you do, whereby the parameters are very, very easy. What are the parameters? Q, which is the quantity of electricity, and what gave rise to quantity of electricity? I times T. So for instance, in another practice question whereby they will give you current and time, that means they did not give you this big Q. So definitely this place I'm having Q, will just change it back to IT. For instance, they gave you current or time, but now they did not give us current and time. They just multiply the two values to form our quantity of electricity, which is expressed in coulombs. Do you get? So what's the value? It is 9650 coulombs. Okay, coulombs, whereby the value 22.4 is there already, and small q is this, and F is Faraday's constant, which is 96500 coulombs. That's the Faraday's constant. Now this must be noted, because this particular question I'm solving here is a very, very popular exam chemistry question, whereby they are asking to get electrolysis, solve volume for electrolysis, then with volume. And the most popular element they always ask is oxygen. Take note, what becomes the charge, which is the Q for oxygen? It is 4 electron, but just take note, it is 4. There's a reaction to explain, which will be provided in my theoretical class on electrolysis. But take note, whenever you see oxygen, what becomes your Q? 4. Do you get? So that's why I'm having 4 here. So what becomes our volume? Volume in dm cube will now be equal to 9650, okay, times 22.4 dm cube over what's our Q now? 4 times 96500 coulombs, whereby volume in dm cube will now be equal to, when we hit our calculator, 9650 times 22.4 divided by 4 times 96500. What's the answer? I'm having 0.56 dm cube as the volume. You get it. Is very easy. It is not difficult at all. So you can see how questions like this have been tackled. You have to follow through the steps. My advice here, just memorize the last formula derived. Okay, since if you're writing the JAMB exam, it's not a theoretical exam, it's just an OBJ exam that you basically just use formula solve. So knowing the formula is important. Okay, but if you're writing an exam like the WAEC examination, NECO examination, and other related exams, chemistry to be precise, you will have to, derive the formula, and and deriving it is not difficult, which I've explained. Do you get? So you can see the volume we got, which is 0.56 dm cube. So you can see how it works without stress. And if you find this video helpful, make sure you click the subscribe button to this video lesson, like this video, and also share these lessons with your friends. So with all this said, let's get into the other case in solving questions in electrolysis, and which is case number 4. Okay guys, let's get into the 4th case in solving questions in electrolysis, and it is on calculations in electrolysis dealing with number of moles. Now, as earlier said in the previous case, where I said that there is a formula I wrote in a box, I said that formula is going to help us solve questions on this particular case we are discussing now, and this was the formula. Yes, and the formula is what? Q is equal to NQF, which is quantity of electricity is equal to N number of moles, small q, charge of elements, F Faraday's constant, whereby in this particular question they're asking us to calculate the quantity of what? Electricity required to discharge an electrode containing 4 moles. This is N, and 4 moles of this particular metal, and you can see that the Q for this metal will be what? 3, because of the 3 plus. And Faraday's constant is always a constant, and it is 96500 coulombs, whereby Q will now be equal to Q will now be equal to the number of moles 4 times charge of elements 3 times Faraday's constant 96500. So what becomes the quantity of electricity? Remember, quantity of electricity is expressed in coulombs, so it becomes 4 times 3 times 96500. That is 11,580,000 coulombs. So you can see how questions on this aspect are being tackled without stress. So let's get into the 5th case in solving questions in electrolysis. Okay guys, let's get into the other case, which is case number 5 in solving questions in electrolysis. Okay, so the question says, how many moles of copper will be deposited by passing 3 farad of electricity through a solution of copper 2 tetraoxosulfate 6. Now you can see that this particular case relates to parameters, which are number of moles and number of farad. Now this must be noted. There is a formula that relates both of the parameter, and it is number of moles is equal to number of farad, or just simply write farad, over Q. And remember, Q is basically the charge of the element. And what's the element here? Copper. Remember, I said when solving questions in electrolysis, you're interested in just the element, and it is copper, which is written as Cu2 plus. Okay, that's the charge. So the charge of copper becomes 2, whereby for the number of farad, the number of farad is 3, as seen in the question, because the question says how many moles of copper will be deposited by passing 3 farad of electricity through a solution of copper 2 tetraoxosulfate 6. So what becomes the Q? It is 2. So what becomes number of moles? Farad, which is 3 over 2. So when we hit this in our calculator, 3 over 2, that's 1.5 moles, because we are looking for what now? Number of moles. So you can see how questions like this are being tackled without stress. So you do well to go watch the Case number 6, that's on the Faraday's second law of electrolysis in the other video lesson, which I'm going to put the link up here and also put the link in the description. Okay, so I hope you find this video lesson helpful. If you find the video lesson helpful, do well to click the subscribe button to this video lesson and also like this video lesson and also share with your friends. Thanks for watching.